So trigonometry deals with the whole idea of relating a linear displacement with curved displacement, linear displacement with curved displacement. Linear in terms of x, y, and curved around a circle. So we're going to analyze that whole process of the relationship between linear motion and curved motion using the unit circle. The unit circle meaning it has a radius of 1. Okay, so let's presume that's radius from the center to the edge. Any edge on that circle has a value of 1. Okay, obviously from that center to here has a value of less than 1. Now, there are 3 trigonometrical functions that have been defined. Sine of an angle is the side opposite to the angle over the hypotenuse, okay, of a right angle triangle. Okay, so let's put it there. So we have sine, agreed. Cosine of an angle is the side adjacent to that angle, meaning next to it, divided by the hypotenuse. Okay. So let's there also. And we've got tangent of an angle is the side opposite to that angle divided by the side adjacent to that angle. So these are the 3 popular known trigonometrical ratios defined, and we all have come across it in our journey through mathematics. Okay, and here they are. Let me just bring them. Bring them there. Right. So therefore now, in the unit circle, we've got 4 right angle triangles. Okay, so here they are. This one here, this one here, this one here, this one here. This here is called the first quadrant. Okay, and we can define a rotation in the counterclockwise direction. Okay, so let's define a rotation in the counterclockwise direction. All right, so we are rotating in the counterclockwise direction, creating an angle. All right. Right, in the counterclockwise direction. Okay, so therefore now, here now will be that horizontal line. Let's say this is angle 0. Okay, and we are rotating counterclockwise. This will be a right angle triangle right there. As you see, you have 4 right angles. So this right angle triangle right here, formed by the vertical and the horizontal, and this will be the hypotenuse. The hypotenuse joins the 2 lines that forms the right angle triangle, or if you will, you can say the box that forms the right angle triangle points to the hypotenuse, and it always has a value of 1 in that case. Okay, so this acute angle right here, this acute angle right here, okay, can be used to talk about sine, cosine, and tangent. in this first quadrant, let's call that quadrant number 1. In this first quadrant, okay, in this first quadrant, that's quadrant number 1 right here. In this first quadrant, right, the vertical line, okay, the vertical side is positive as well as the horizontal side. Yes, because this is 0, this is positive, this is positive. To the left is negative and down is negative. Okay, so both the horizontal line and the vertical line are positive. So in this first quadrant, all 3 ratios are positive because opposite and hypotenuse, the hypotenuse is always positive. The hypotenuse is always considered positive because it's a diagonal joining the center to the edge, yes? But the vertical and the horizontal, they carry the signs as in the axis, okay? So therefore now, a positive divided by a positive is a positive. Sign is positive in the first quadrant. A positive as the adjacent to the angle, next to the angle, divided by the hypotenuse, positive. Cosine is positive. Tangent is the opposite, the side opposite to the angle. So try not to, try to remember to say opposite to the angle that you're referring to. No, usually you would say just opposite and you just say adjacent, but you can practice saying opposite to the angle, because if this angle alpha was here, okay, if this angle was here, this vertical line will not be opposite to the angle, it will be the adjacent now, okay? So bear that in mind. And this horizontal line will not be the adjacent, you know, it will be adjacent to the angle. Okay, so you can say the hypotenuse. Yes, you can say the hypotenuse. You can say that, the hypotenuse. The hypotenuse. Yes, you can say that. But it is not wise to say the opposite, because opposite and adjacent are relative to the angle. Okay, so there is no such thing as the opposite and the adjacent, because adjacent and opposite can change. A side that was once opposite can change to adjacent based on where the angle is located. Okay, so bear that in mind. So always practice saying opposite to the angle and adjacent to the angle. So all 3 ratios are positive because the vertical as well as the horizontal are positive. Okay, and another thing to note, as you're rotating, you see, this is 0. The angle is 0. If you rotate, the radius rotates anti-clockwise, the angle increases. As you can see, the vertical is increasing and the horizontal is decreasing. If it rotates a little further, as you can see, this brown horizontal vertical line and this purple violet line, the horizontal decreased and the vertical decreased. So therefore now, when the radius rotate completely vertical, then there will be no, all right, there will be no horizontal. And in such a case now, you know, that will be a 90 degrees. So that is why now, you know, that's why sine of 0 is 0. Sine of 0 is 0 because sine depends on the side opposite to the angle. So at 0 angle, there is no opposite. The length of the opposite side to the angle is 0 because the angle is 0. And the hypotenuse on 0 divided by 1 is 0. Okay? But when you come to 90 degrees now, the vertical side is the same length as the hypotenuse. Okay? So that's why sine of 90 is 1. And you can prove it in your calculator, or also take out your calculator, because in trigonometry, if you type sine of 90, you're going to get 1. Because now at 90 degrees, the vertical line is the same length as the radius. Okay, so as you increase from 0 to clockwise, counterclockwise, the sine of the angle increases up to 1. Sine of 0 is 0. Sine of 30 is 0.5. And sine of 90 is 1. Okay, so you can prove that in your calculator because the vertical is increasing. Cosine now, cosine of 0 is 1 because at 0, okay, let's put this 0. The horizontal line, which is adjacent to the angle, is the same length as the hypotenuse. Okay, so that is why cosine of 0 is 1. So you can prove it in your calculator. The cosine of 0 is 1 because the horizontal line, which is the side adjacent to the angle, is the same length as the hypotenuse. Okay. However, cosine of 90 is 0 because at 90 degrees, there is no adjacent to the angle. The adjacent to the angle is 0, has decreased to 0. Okay. So therefore, that is why cosine of 90 is 0. So therefore, cosine starts at 1. Cosine of 0 is 1, and it decreases to 0 at 90 degrees. Cosine of 60 degrees is 0.5. So you can look it up. What about tan? Tan depends on the ratio of the opposite to the angle divided by the adjacent to the angle. At 0 degrees, right, let's put this as 0 degrees. At 0 degrees, what happens? At 0 degrees, the adjacent is equal, or you can say the adjacent is 1. Okay, the adjacent is 1, but the side opposite to the angle is 0. So opposite 0 divided by 1 is 0. So that is why tan of 0 is 0 because there is no opposite to the angle. Okay, but there is adjacent. Okay, so 0 divided by 1 is 0. Now, tan of 45 is 1 because at 45 degrees, you have an isosceles right angle triangle. The opposite to the angle and the adjacent to the angle are same length because remember, the total angle in a triangle is 180 degrees. This is already 90, 45, 45, 90. You have an isosceles right angle triangle. This vertical side, which is the opposite to the angle, this horizontal side, which is adjacent to the angle, are both equal in length. So therefore, now tan of 45 degrees is 1. So tan increases from 0 to 45. Now look at what happens now. Something interesting is happening at tan of 90. At 90 degrees, okay, at 90 degrees, the adjacent is 0. At 90 degrees, the adjacent is 0. Okay, and the opposite to the angle is 1, which is equal to the length of the of the radius. Okay, here it is at 90 degrees. So you have 1 divided by 0. 1 divided by 0 is, if you put that in your calculator will tell you undefined. Some mathematicians will tell you infinity. 1 divided by 0 is undefined, 1 divided by 0 is infinity. So tan increases from 0 to infinity, okay, in the first quadrant. And just remember, in the first quadrant, all 3 ratios are positive.